So what other knowledge is there out there that we simply haven't captured? We think we're quite cool, don't we, in making hollow core concrete slabs to cut down the self-weight. I'm sorry, the Romans did that, and we've got evidence of it in Bath. We think we're quite cool making waffle slabs in concrete to cut down the self-weight whilst allowing us to span two directions. The Pantheon demonstrated that. Underfloor heating, I could go on. Wind catcher, well actually, this isn't Roman, this is a Gulf Coast wind catcher in a reproduction hut, and we know that the wind catchers that are manufactured in the UK are actually direct copies of those things. But, there we go. There is plenty of precedent for all the things we think are really clever now. And of course, Gaudi was a master at making the humble brick beautiful and exciting. And these days, we've reduced it to mere infill between our concrete frame buildings. Concrete, of course, is much loved of construction, as Giles said earlier. It's low in embodied energy compared to some other materials. But actually, whilst it's incredibly flexible in creating architecture and creating forms, it's incredibly inflexible in having any further life. If you want to take down a pre-stressed concrete building like this one in the city, you have to go to enormous lengths just to take that building down, and it has to be taken down because you can't adapt it. So whilst concrete is incredibly flexible in making the first incarnation of an architecture, it's incredibly inflexible for the rest of its life. This is Saddam's folly in Baghdad. Saddam had this ambition to build the largest mosque in the world, so he started. This was to be the site for the new Iraqi parliament building, only it's going to cost nearly as much to take this structure away as it will do to create the entire new parliament. So concrete, it's great stuff, but you've got to be really, really clever to make a building in concrete which is going to be sufficiently flexible and sufficiently adaptable for all the future uses we might need to put it to. If we've got 40 years to accommodate 3.5 billion new urban dwellers, that means we have to build new urban fabric to the same extent as Greater London every month. We don't have time to make mistakes. You could look back over history and you could say that the built environment that we inhabit now has basically been created in the last 400 or 500 years. We've had plenty of time to make mistakes and adapt and move on. We've got to create the same amount of built environment again in 40 years. There just isn't time to make mistakes. We certainly don't want to be setting those mistakes in concrete. If we were to talk about sustainable construction, what do we actually mean? Sustainability is a meaningless word, of course. Sustainability means simply the property of being sustainable. To be sustainable means to be capable of enduring. So if we look at constructions that have endured, what do we learn from them? Well, actually, some of the biggest structures that have endured were also Roman. And they were made of masonry. They could be adapted. They weren't made of monolithic concrete, which is incapable of adaptation. Great chunks of Roman masonry still exist all over hostile parts of the world, like the north of the UK. Roman masonry construction resists earthquakes. Okay, that's because it's massively over-engineered. But masonry has this flexibility and adaptability, and you can repair it. It's interesting. And what's really interesting about masonry bricks is that they are continuously reusable. Not recyclable, not remanufactured like steel, but reusable. And the history of urban development in the UK is full of buildings being taken down and rebuilt as something else. And St Albans Cathedral, the tower of St Albans Cathedral, is built almost entirely out of Roman bricks. Look up close, you can see them. These are all Roman bricks. In fact, Even in the modern bits of St Albans Abbey, you can still find the odd Roman brick mixed in with Victorian and even modern manufactured brick. So if you're talking about sustainable buildings, what are we talking about? Are we talking about the built form itself, or are we talking about the components and the materials that you use to make the building, and you make them infinitely recyclable? Because let's face it, once something's been manufactured, if you can go on reusing it and reusing it and reusing it, it changes the sustainability paradigm completely. So do we need to rethink? What other lessons? Here's a few other examples. Traditional housing in the Gulf, in the Arabian Gulf, was based on courtyards. Very, very clever bits of outdoor environmental engineering. The significant thing is that the sky, because there's very little water in the sky, very little thermal mass, it's got a high radiant transfer. It gives it an effective temperature of about 5 degrees Celsius. The air temperature in the Gulf is easily 35 on a lot of occasions. Trees planted in courtyards bring the local temperature down to around about 28 through transpiration and evaporation. Shaded walls achieve the average day-night temperature of around about 33 degrees. In the sunshine, obviously it's much, sunny walls are absorbing heat from the sun, so they're much warmer. And these clever devices of allowing breezes through layers and layers and layers of thermally massive construction, using the night cooling principle, brings the temperature of those down. So when you put all that together and you calculate what a human body would perceive as the resultant temperature in that space, it's around about 32.5 degrees. It's 2.5 degrees cooler than the ambient temperature as a result of this exposure to the sky and surrounding thermal mass and to trees. Now, all these buildings are being wiped away, and they're being replaced with our pastiches of the eastern US seaboard. Here, the sky is still 5 degrees, but now the sky angle exposed to you has been reduced to a sliver by all of these tall buildings. The thermally massive construction has been replaced by steel and glass with high specular reflection, so the sunlight simply bounces around between these buildings. The light-coloured sand at your feet has been replaced by blacktop, and the temperatures of all of these things are going up. And as a result, the temperature that you sense in downtown Dubai or Abu Dhabi is actually closer to 38 degrees, 3 degrees warmer than the ambient temperature, and 5.5 degrees warmer than you would feel if you were in a courtyard house. And of course, the work that's been done on densification of housing says that we don't necessarily have to go high in order to be dense. And if we can maintain the exposure to the sky in these places, you can change the complete feel of the downtown areas.